So today we're going to be doing a titration. So we're going to first determine the initial volume of this burette here. And it's really tall, so we're trying to stand on my tiptoes to read below the meniscus. And it looks like it's at 0. Yes, it's at 0.00. So next what we're going to do, we have the titration solution here, which is KHP and phenolphthalein, which is an indicator, and this is sodium hydroxide. So we're going to titrate the sodium hydroxide into the KHP. So we're going to turn the knob, and you're going to get a steady stream. And you have to swirl the solution so that you get an accurate reading of the endpoint. Because the phenolphthalein is in there, it's an indicator, so it's going to turn a light pink. And if you don't swirl it, you may get an inaccurate representation of the endpoint. So as you can see here, the volume is going down, and when we get to the finished titration, which is the light pink at the end, we'll read the final volume so that you can see how much of the solution of NaOH, which is sodium hydroxide, actually went into the titration. So we have reached the end of our titration because the solution is a light pink, as you can see, because we're holding it on this white paper on the background here. So now we're going to read the final volume. We'll read it again at the bottom of the meniscus. And this one looks to be about 26.47.
Okay, so I'm going to read the initial volume first, and I'm short so it's hard, but it looks about 0.02 milliliters. And so now I'm going to titrate the sodium hydroxide into the KHP. Alright, so you're done because our solution is a very faint pink. You can see at the bottom here. Final volume.
Okay, as you can see, our initial volume was at 0 milliliters, and our ending volume was at 39. So our final volume is at
33.5.
The burette was rinsed with water in solution 3 times before each use.
The purpose of a titration is to determine the concentration of an analyte in solution, the stoichiometry of a reaction, the number of electrons gained or accepted in a redox reaction, and solubility products.
To read a volume, you look at where the bottom of the meniscus touches the unit marks on the glassware, and then approximate the next uncertain digit. To determine the unknown variable, the mass, volume, and concentration of the standard solution, the change in volume of the analyte solution, and the balanced chemical equation must be known.